500 m beneath Antarctica, where sunlight has never reached, something is alive. Amphipods drifting in total darkness, cut off for thousands of years. Ice here can be nearly 5 kilometers thick. From above, it looks empty, but it isn't. Beneath the surface are uphill flowing rivers, lakes larger than cities, active volcanoes in million-year-old air. All locked inside Earth's largest freshwater reserve. And now the world's most powerful nations are racing to control it. China is building new year-round stations. Russia is running seismic surveys in contested territory. Antarctica is protected by an international treaty that bans mining and territorial claims. In 2048, that protection can be reviewed. And when it is, presence becomes power. So what is under the ice that is worth this much effort? What are they actually looking for? This is new nature. And we spent weeks pulling together the latest research from glaciologists, geophysicists, and ice core scientists. Antarctica is far more interesting and far more valuable than it looks from above. To see what nations are really chasing, we have to go under the ice. But first, let's zoom out. Antarctica is the 5th largest continent on Earth, larger than the United States and Mexico combined. It holds 70% of the planet's fresh water locked inside an ice sheet that is thick enough to bury the Alps. It's the coldest, driest, and windiest place on the planet. Temperatures drop to -90 degrees Celsius, winds can exceed 200 miles per hour. In winter, parts of the continent don't see the sun for months at a time. And yet life exists here from the surface to the ocean and deep beneath the ice. Snow falls in Antarctica year after year and compacts under its own weight. Each layer is a year like tree rings. As the snow compresses, air gets trapped between the grains. Tiny bubbles of atmosphere sealed in time. These rods are ice cores. Scientists drill down and pull up long cylinders of frozen history. Trapped inside are tiny bubbles of ancient air. The deeper the core, the further back in time. This is one of the oldest continuous ice cores ever recovered. Drilled from nearly 3 kilometers down, it contains air that's about 1.2 million years old. If it warms, that record is lost forever. This is how we know what Earth's atmosphere was like long before modern humans existed. The ice preserves carbon dioxide levels, methane, volcanic ash, and temperature signals. A complete atmospheric archive. It records when the Sahara was green and when mammoths walked the Earth, when carbon dioxide levels were half of what they are today. The ice doesn't forget, but this is still just the top layer. Before we go deeper, look at what happens to snow once it hits the surface. Most of Antarctica is covered in bright reflective snow. But in some places, powerful winds strip that snow away, exposing something unexpected. Fields of blue ice. This ice began as ordinary snowfall, compressed until air bubbles were forced out. With no fresh snow on top, light penetrates deeper and the ice absorbs reds and yellows, leaving it glowing blue. In some regions, blue ice reveals ice that's hundreds of thousands of years old. Elsewhere on the surface, the opposite happens. Snow keeps falling year after year. It piles up, compresses, and buries whatever lies beneath it. Mount Erebus, the most southern active volcano. Hot volcanic gases escape from vents on its slopes, and where those gases meet the ice, they carve warm caves. Inside those caves, scientists have found mosses, algae, and DNA sequences that don't match anything we've seen before. Life finding a way in the least likely place, but the strangest thing near the surface isn't alive. In 1979, Air New Zealand Flight 901 crashed into Mount Erebus, killing all 257 people on board. The terrain was unstable. The ice is constantly moving. Full recovery was never possible. Snow and ice quickly buried much of the wreckage. Parts of the aircraft and possibly human remains are still likely in TMB beneath the ice. And as we go deeper into the ice, you'll start to realize Antarctica is much more than just ice and snow. It also has heat, history, and it's hiding things we're not supposed to find. We're about 1,000 foot down now, and this is where Antarctica stops behaving the way people expect. Most people think of Antarctica as one giant block of melting ice. In reality, it's doing two different things at once. In West Antarctica, ice is thinning fast. Glaciers are accelerating toward the ocean. Ice shelves are breaking apart. Some of the fastest ice loss on Earth is happening here. But East Antarctica tells a different story. It's colder, thicker, and in some regions, snowfall has actually added ice. At least for now. Satellite measurements show that despite these gains in the east, Antarctica as a whole has been losing ice for decades. But the continent isn't responding as one system. That's the paradox. And it's why this layer matters. If we don't understand what's happening here in this compressed transition zone inside the ice, we can't understand what comes next. So, we keep going down. You're more than a kilometer down now. The pressure here is extreme. Between the ice and the bedrock below, water is moving. Beneath Antarctica, thousands of rivers and lakes from a connected drainage system. Some of these subglacial lakes hold volumes of water comparable to major US reservoirs. When they drain, it happens fast. In some events, billions of liters of water are released over just a few days, comparable to a large fraction of a lake, like Lake Me moving underground, unseen beneath the ice. That water can travel hundreds of kilometers across the continent. As it redistributes below, the ice above responds. The surface lifts and settles by meters as pressure shifts underneath. Like weight moving across a frozen shell. We've barely touched this world directly. If you add up every place humans have physically reached beneath the ice, it covers about the size of a basketball court. Helicopters sweep low over the ice carrying massive electromagnetic sensors. Huge loops suspended beneath them. Systems like SkyTem send signals down through ice and rock, revealing what's frozen, what's liquid, and what's moving below. We're echolocating a hidden continent. This deep red stain spills from Taylor Glacier. It's streaking the ice like an open wound. Scientists call it blood falls. When explorers first saw it in 1911, no one could explain it. Algae was suspected, but algae needs sunlight. And this water comes from deep inside the ice. Look closely and you'll see the water comes out clear. This is ancient briny water, more than twice as salty as the ocean, which keeps its liquid even at -5 degrees Celsius. It's been sealed beneath roughly 400 m of ice for millions of years. Dissolved iron reacts with oxygen, oxidizing on contact and staining the ice red. Blood falls gives us a glimpse into what these hidden rivers transport beneath Antarctica. Iron, organic carbon, and nutrients. There are thousands of subglacial outflows like this across Antarctica. Most never reach the surface. When that nutrient-rich meltwater enters the ocean, it fuels phytoplankton which support krill and everything above them. The system begins beneath the ice and ends with the largest animals in the ocean. Blue whales, the largest animals to ever exist on Earth. In the 20th century, we almost wiped them out. Between 1904 and 1967, more than 360,000 whales were killed in Antarctic waters alone. Blue whale populations collapsed by 97%. They're recovering, but there's still a problem. We don't understand them well enough yet. Where they breed, how they migrate, what conditions they need to survive in a rapidly changing ocean. And researching animals this large in a place this remote takes resources most people never see. That's why I became a Planet Wild member. Planet Wild is a community that funds one concrete nature protection mission every month. Think of it as crowdfunding for nature. What I like about it is that it's not abstract. You don't just hear about problems, you see the work being done. Every mission is documented and published on YouTube within a few weeks. I joined because it's one of the few ways I've seen where you can actually follow nature conservation work from start to finish. One of the missions I supported focused on blue whale research. Planet Wild funded drone-based monitoring that let scientists study blue whales without disturbing them and made the resulting data openly available. For me, that fits this story. The Antarctic ecosystem only works if we understand it well enough to protect it. If you want to support this kind of work, you can join Planet Wild, too. You'll start having an impact as a member right away. And as a thank you, I'm covering the first month for the first 100 people who sign up using the link below. Scan the QR code or click the link in the description to become a member now. You're more than 3.5 kilometers down now. The pressure is crushing. The darkness is absolute. And beneath the ice lies one of the largest lakes on Earth, Lake Vasto. It is 240 kilometers long and 50 kilometers wide and completely sealed beneath the ice for millions of years. It has never seen sunlight. It's been isolated from Earth's atmosphere longer than humans have existed. A potential habitat for microbial life unlike anything studied before. Lake Vasto isn't unique. There are nearly 700 subglacial lakes scattered across Antarctica. In the few scientists have sampled, they've already found evidence of life. In Lake Willins, microbes survive by extracting chemical energy from rock. In Lake Mercer, researchers found microbial signatures preserved in the sediments. And remember the amphipods from the beginning. They were found beneath the Kamai stream, hundreds of kilometers from sunlight, swimming in total darkness. That makes Antarctica one of the closest natural analogues we have to icy worlds like Europa and Enceladus. Moons with oceans sealed beneath frozen shells. If life can exist under kilometers of ice beneath Antarctica, it widens the range of conditions we have to consider elsewhere in the solar system. Antarctica isn't hiding aliens, but it's showing us what alien life might look like. You're nearing the bedrock now, and it's not the solid frozen foundation most people imagine. Beneath West Antarctica are dozens of volcanoes hidden under a kilometer of ice. Some of them are active. They don't erupt upward. The weight of the ice suppresses explosive blasts. Instead, heat builds below, melting the ice from underneath and carving chambers of water and steam. The heat destabilizes glacier and accelerates ice loss. Scientists have found ash layers trapped in ice cores, evidence of eruptions that happened while the ice was forming. More recent seismic data suggests some of these volcanoes are active today. This geothermal heat wasn't fully accounted for in early ice models. It helps explain why parts of West Antarctica are changing faster than expected. The ice isn't only responding to warming from above, it's being heated from below. But these volcanoes are only part of the story. They sit on the surface of something much larger. This is the bedrock. The actual continent buried beneath everything you've descended through. Using data from millions of measurements, scientists can digitally strip away the ice. This is Bed Map 2. When the ice disappears, the surface you thought you knew vanishes with it. What's left is a vast, rugged landscape. Mountain ranges comparable to the European Alps lie completely buried beneath the ice. The Gambortsev Mountains stretch across the interior, their peaks rising thousands of meters, unseen for millions of years. Denman Canyon cuts through the bedrock nearby, the deepest land canyon on Earth, plunging more than 3.5 kilometers below sea level. Ancient river valleys run between them, preserved exactly as they were tens of millions of years ago. Antarctica isn't one continent underneath. It's two very different geological worlds. East Antarctica is ancient, thick, and stable, part of one of the oldest pieces of continental crust on Earth. West Antarctica formed differently. Over tens of millions of years, tectonic forces stretched the crust apart. It thinned, fractured, and sank, creating deep basins long before ice ever arrived. That thinning brought heat closer to the surface, helping explain why West Antarctica hosts dozens of volcanoes beneath the ice. When Antarctica drifted south and ice began to accumulate, those low fractured regions filled first. Strip away the ice today and much of West Antarctica sits below sea level. The continent breaks apart into islands and highlands. Fossilized pollen and root systems preserved in the rock show us this was once a green forested land. With rivers and temperate climates when Antarctica was part of Gondwana. And then there's the Wilkes Land Gravity Anomaly, a circular structure 300 kilometers wide buried beneath East Antarctica. Its origin is still debated. It may be one of the largest impact scars on Earth or something else entirely. Whatever it is, it's massive and it's hidden. For millions of years, the weight of the ice has pressed Antarctica downward, pushing the crust into the mantle below. When ice is removed, the land doesn't just sit there. Over centuries to millennia, it slowly rises back up, changing coastlines, altering drainage, and reshaping stress deep within the crust. This bedrock remembers a world without ice. The surface you started on does not. Antarctic Treaty, Resources, and the 2048 deadline. And this is what nations are positioning themselves to control. So why does any of this matter? Why are nations racing to build stations, run surveys, and establish a presence across Antarctica? Antarctica shares the same deep geology as South America, Africa, India, and Australia. Continents rich in coal, oil, metals, and rare elements. Geological surveys suggest vast resources buried beneath the ice, potentially worth trillions. For now, all of it is protected by the Antarctic Treaty signed in 1959, which designates Antarctica as a zone for peace and science, prohibits military use, and suspends territorial claims. But in 2048, that ban can be reviewed, and that review could open the door to extraction. Russia has carried out extensive seismic surveys and mapped potential oil and gas resources in Antarctic waters. China is rapidly expanding its Antarctic program, building new year-round stations and investing heavily in logistics, mapping, and polar research. Meanwhile, The United States Antarctic program is facing aging infrastructure, funding uncertainty, and growing pressure to prioritize elsewhere. The subglacial lakes, the hidden biosphere, the ancient rivers, the ecosystem powered by iron and nutrients flowing into the Southern Ocean. All of it exists in a fragile balance that took millions of years to create. 5 kilometers of ice cover a continent that stores ancient air, channels rivers through total darkness, and supports life without sunlight. Entire mountain ranges lie buried below the surface. The bedrock beneath Antarctica still records a time when this land was green. Antarctica is not empty, and it's not simple. It operates as a connected system that runs from bedrock to ice to ocean. Heat shapes the land. Ice controls the water. Water carries nutrients. Nutrients sustain life.